Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 6.6 entitled Solving Absolute Value Equations. And today we're going to solve absolute value equations. And you have to remember that absolute value is the distance that a number is away from zero on the number line. And it always has a positive value. And when we have an absolute value equation, it's an equation where the variable is inside that absolute value sign or in between the absolute value bars. So it'll look like the absolute value of x equals 7. So basically, when we're solving that type of a problem, you have to ask yourself what number would be substituted in there for x that has an absolute value of 7. So there's really two answers because 7 is 7 units away from 0 and negative 7 is also 7 units away from 0. And remember, that's the definition of absolute values, how far a number is away from 0. So when we're dealing with absolute value equations, we're going to get two answers. And we want to treat those absolute value bars like they're grouping symbols. So we kind of need to treat them like they're parentheses in a way, which means if we're going to solve for something inside of them, we have to get them completely by themselves first. So that's our first step here when we're solving absolute value equations. We have to get the absolute value all by itself, or the absolute value bars. And then we have to set up two equations because we're going to have two solutions. So one's going to be positive and one's going to be negative. Okay, like up here, we're going to have a positive 7 and a negative 7. Okay, and I'll show you how we set that up and how we deal with the positive and negative in just a moment. And then you solve each little equation that you have set up, and then you have to check your answers. Because sometimes the value that you get when you substitute it back into the original absolute value equation, it doesn't give you a true statement. Now, sometimes they try to trick you and they will take the absolute value of some number and they will set it equal to a negative value, like the absolute value of x equals negative 5. And that can't be true, okay? Because the absolute value always has to have a positive value. It's a positive distance away from 0. So when that happens, you just say that there's no solution. So the absolute value of a number can never be a negative number. So the absolute value of 5 is 5, not negative 5. Okay, so let's take a look at some examples here. We have example 1, we have A through F, and that's all that we have. Okay, so we're going to write the absolute value, or solve the absolute value equation that we're given, and then if the equation has no solution, we're going to write no solution. Okay, so for our first problem here, we have the absolute value of x equals 32. And when students see problems like this, they tend to get a little tripped up on them because they think something is missing. Okay, there's no other number inside the absolute value bars with the x that they have to get rid of. So all you really have to do here is set up your two equations. X equals 32 and x equals negative 32. Those are the two numbers that you could substitute in here for x and still take an absolute value of and get a positive 32. So these problems are meant to be nice and meant to be easy. They're just conceptual ones. They're ones that they want you to think through. Now for part B, this is one that I was talking about earlier, how when you have the absolute value of something, it cannot be equal to a negative number. If we put 5 in there, the absolute value of 5 is 5. Even if we put negative 5 in there, the absolute value of negative 5 is 5. So this one is no solution because you can never have an absolute value set equal to a negative number. You can't take the absolute value of something and get a negative number as an answer. Okay, so example A and B are meant to be very straightforward types of problems. But for C and D, this is where we start to see more of our work. Now for C, we have a -4 in here, a -4 with the x. So if we're trying to solve for x, we're going to eventually have to add that 4 out of there. Okay, but there's really two numbers in here that could get us the absolute value of 5. Okay, so we could take all of this stuff and we could say, hey, if that equaled 5, the absolute value of 5 is 5. And if all that stuff equaled -5, then the absolute value of -5 is 5. So that's why I'm going to take the x minus 4 and I'm going to set it equal to 5. And then I'm going to take the x minus 4 and set it equal to -5. Okay, so it's basically like taking the stuff inside the absolute value and setting it equal to the answer and then the opposite of the answer. Then you're going to solve each of these. So I'll add the 4 over. So I get x equals 9. Add the 4 over. Now you're doing the same step, but you get a different answer. You get -1. Okay, so I have two possible answers here. Now I'm going to check them. If I take 9 and substitute it back in, 9 minus 4 is 5. Absolute value of 5 is 5. Okay, so x equals 9, that's a true statement. So that's an answer. If I put -1 in there, -1 minus 4 more, that's -5. Absolute value of -5 is 5. Okay, so good. So that's my other answer. So I get two answers here. Okay, now for part D, I have to get rid of that 1/4, so I'm going to multiply by the reciprocal. But again, we want to think, okay, what number if I put in there, if I substitute it in for the whole expression, would get me 8? Well, that would either be an 8 or a -8. So I need 1/4 x set equal to 8, and I need 1/4 x set equal to a -8. And then to solve for the x, I'm going to multiply both sides by 4. So x equals 32. And then x equals a -32. Now I want to check them. If I took 32 and substitute it back in for the x, 1/4 of 32 is 8, and the absolute value of 8 is 8. So that's a true solution there. -32, 1/4 of -32 is -8, and the absolute value of that is +8. So that solution works as well. Now you might not always have a situation where both answers are actually your answer. It might only be that one of them works, or neither of them work. Okay, now for part E, we have a more complex expression inside our absolute value here. But again, we just have to say, okay, what if I substituted it in for that whole 2x plus 3, what would I have to take, what number do I need? So that if I take the absolute value of it, I get 9. Well, I could put a 9, because an absolute value of 9 is 9, or I could do -9. So that's why I'm going to take 2x plus 3, set it equal to 9, and then the 2x plus 3, and set it equal to -9. And then I'm going to subtract the 3, so I can solve for x. So I get 6, and when I divide by 2, I get x equals 3. Then I'm going to do the same steps over here, but because I have this all set equal to a -9, I get a different solution. I end up getting -12. When I divide by 2, I get -6. Now again, I'm going to check these answers first before I just walk away from my problem. 2 times 3 is 6, plus 3 is 9, and the absolute value of 9 is 9. Okay, so that's a solution. And then -6 times 2, that's a -12, plus 3 is a, not a 9. Okay, so again, if we double check this one, -6 times 2, that's a -12. Oh wait, plus 3 is a -9, and then the absolute value of -9 is 9. Okay, all right, good. So that one does check out. So sometimes students think that just because this is a negative number, they can't have that as an answer. Okay, you can get that as a value for x, you just can't have the whole absolute value set equal to a negative number. Okay, now part F. This one has one extra step that we have to do first. Okay, and on our previous slide, we said that the very first step we have to make sure that's done is that we have to have the absolute value all by itself. So I have the 3x minus 2. I'm taking the absolute value of that. That's okay. We'll solve for the x in a moment. But I also have this plus 7 that's added on at the end. So I have to get rid of that first. So then I'll have the absolute value of 3x minus 2 equals 10. And usually students then just start solving that and get one answer. But remember, we need two possible solutions here. Because this means I took the absolute value of something and I got 10. Well, that something that I could take the absolute value of could be a positive 10 or a negative 10. So now I have to do the 3x minus 2 equals 10 and the 3x minus 2 equals negative 10. So I'm going to add the 2 over. So 3x equals 12. And then when I divide by 3, I'll get x equals 4. And then for the other problem, I'm going to do the same steps. I'm going to add the 2, but I end up getting a different number. I'm going to get negative 8. And when I divide by 3, I'm going to get negative 8 thirds. Now, a lot of times students think that you can't have a fraction for an answer. So this is why we always substitute to see if it works. So if I take 4 and substitute back in for x, 3 times 4 is 12, minus 2 is 10, absolute value of 10 is 10, plus 7 is 17. Okay, so that works. Now if we do that for the negative 8 thirds, remember negative 8 thirds times 3 over 1 is basically going to cancel out the 3's. So I'll end up getting a negative 8 minus 2, which is a negative 10. Absolute value of negative 10 is going to be positive 10 plus 7 is 17. So yes, that answer works. Even though it's a fraction, when I substitute it back in, I still get a correct answer or true statement. So this is your homework to practice these concepts. Make sure that when you see those absolute value bars, since there's 2 of them, that's kind of a visual reminder that you need to set up 2 equations when you're solving. And if you have any questions, come on in and see me before school.